That's perfect. You know that that has balanced out perfectly for you. Now, the other kind of balancing equation they might give you is where there's a subscript attached. Remember that? So an example of that would be something like this equation here. Okay, I minus and then S4. And the rest of the rules are the same. So you sign oxidation number 7, 0. I know there's 2 iodines, but remember the substance has to be, the element has to be bonded to something else. Okay? Minus 2 for the oxygen, x that. So 2x minus 6 equals minus 2. Don't forget that there's a charge on that there. So when I work that out, I'm getting 2x is equal to plus 4. So then, x is equal to plus 2 there. Minus 1 is showing that to me there. Minus 2. 4x minus 12 is equal to minus 2. 4x is equal to 10. So there, x is equal to plus 2.5. Okay? Now, what has been oxidized? Well, the sulfur's been oxidized. What has been reduced? The iodine's been reduced, okay? So pull those out separately now. So what's been oxidized and what's been reduced, okay? So we said a second ago. Now, notice the subscripts. Look, so you're going to have to say to yourself, let me just rub that out there because it's getting in my way. You're going to have to, you're going to have to say to yourself there that each sulfur, now, it's going from plus 2 up to 2.5. So each sulfur gains a half an electron. Now, lads, remember oil. So, loses, I should say. Each sulfur loses a half an electron. Attach the subscript now, S2, so is going to actually lose 1 full electron. Okay, attach the subscript, 2 times a half is 1. Look at the iodine, same sort of an example. Each I gains, now what's happening with the iodine? It's going from 0 down to a minus 1, so it gains 1 electron, but when you attach your subscript, 2 electrons. So you have the sulfur, the S losing 1, the iodine gaining 2. Balance the atoms, multiply that by 2, this by 1, insert in that ratio. So I'm putting a 2 in front of the sulfur, okay? So I'm going to have 2 in front of the sulfur like that, 1 in front of the iodine, so I just keep it like iodine like that there. And then the last thing that you need to do once you've inserted your ratio is balance your atoms. The 4 sulfur there. I have 2 iodine here, so I have to put a 2 in front of that. Now what about the oxygen? 2 times 3, that's 6, and I have 6 over there, so that's fine. And then lastly, check your charge. 0 there, 2 times minus 2 is minus 4, and is that equal to minus 2, because 2 times minus 1 is minus 2, and there's minus 2 there, it is. So again, just be awful careful. Spot the subscript, write it as normal, and then physically attach in the subscript, but don't forget to double the number of electrons as well, okay? Now, the last thing now, lads, that I wanted to run through there was that experiment. The new revision book does out that experiment, but it's poor enough, to be honest, because it's all in tables, in words, and it's very hard to kind of understand what they're doing. I would have given you a photo, but I'll attach it on Edmodo, of the older revision book, and it kind of did it out in test tubes. I think it's easier. The first part of it there is you're showing that the halogens act as oxidizing agents. Now remember, if it's acting as an oxidizing agent, it is being reduced itself. So it's being reduced. And the other thing to bear in mind is that when you're talking about the halogens, you're talking about chlorine, bromine, iodine. They're group 7. So what do you know about those atoms? They have 7 electrons of their own. They need to get 1. So they want to be reduced, okay? Now, in the first test tube, you've got sulfite ions, SO3 minus 2. And what they do then is they tell you to put in either chlorine water, bromine water, or iodine, a halogen, chlorine, bromine, or iodine. Now, I'm just going to say that we're putting in chlorine water here. And you add some chlorine water. You don't actually observe anything, but you're going to test now for sulfate. Now, if you figure out the oxidation state of the sulfur there, you'll find the sulfur is plus 4 here and it's plus 6 here. So what has happened? The sulfur has been oxidized. So you've gone from a sulfite ion to sulfate ion. But what has happened to the chlorine? Well, if the sulfur has been oxidized, the chlorine has been reduced. So the chlorine has gained 2 electrons and you formed 2 chlorine ions. Now you cannot see the chloride ions or you cannot see the sulfate ions. So what you have to do now is you have to test that the test tube here contains sulfate. So you test for sulfate. And how do you test for sulfate? You add barium chloride, you will observe the white precipitate, you add dilute HCl, and the precipitate stays for sulfate, dissolves for sulfite. So that precipitate stays, which proves to you that the sulfite has been oxidized to sulfate. The other one that they do to prove that halogens act as oxidizing agents is they have iron +2 in the test tube. Again, chlorine, bromine, iodine, whichever you want to add in. And what happens here is the Fe+2 is oxidized to Fe+3. You're familiar with that from your redox titrations. And what happens to the chlorine? Again, same idea. The chlorine is going to be reduced. So the chlorine gains, this is being oxidized, this is losing electrons, so the chlorine gains 2 electrons there. Now, again, how do you test for Fe+3? You add sodium hydroxide and you'll see a green-brown precipitate, which tells you that there's Fe+3 present. You wouldn't see that green-brown precipitate if it was Fe+2. All right? So that's the first part of the mandatory experiment. Just showing that they actually do act as oxidizing agents. In the second part then, they're kind of talking more about the reactivity of the halogen. So what they do, one thing, we'll just do that there first. Chlorine, bromine, iodine. This is your halogens, your group 7. Okay, as you go down, the electronegativity value decreases. What does electronegativity value mean again? It's the relative attraction that an atom has for what? Electrons. So the pull, remember the tug of war? The pull that the atom has for the electrons. So chlorine has the greatest pull, then bromine, and then iodine. So what they do is they put a solution of KBr into the test tube here. So you essentially have Br minus ions in that test tube. And then they pour in some chlorine water. Now, what will gain electrons? Br minus or chlorine? Chlorine. Chlorine is higher up. So chlorine is more electronegative. So what happens is that the chlorine takes those electrons there. So you have the Cl2 takes 2 electrons from the bromine. So the chlorine's taking electrons. Now if the bromine is taking if the chlorine is taking electrons, then the bromine is losing. So what happens is that 2 of those Br minus ions lose an electron each, and you form bromine. And bromine, you'll notice the appearance of bromine because it's got a colour, it's orange in colour. So you'll see that orange colour forming as you're making bromine. Okay, and what will happen here then is you form 2 chloride ions. So why is the chlorine taking the electrons? Because it's more electronegative. It takes the electrons from the bromide ions, forming bromine. You're forcing the bromide ions then to give away their electron, to lose their electron, and so you'll form Br2 from that. In the second test tube then they have Ki in here, so that's K plus and I minus, so it's I minus ions that we're interested in, and you can put chlorine water into that, okay? When you put chlorine water into that, again I had it up here, remember, chlorine, bromine, iodine, so chlorine's going to take, so you have the I minus ions, 2 of them, lose an electron each, and you form iodine. And you all know the colour of iodine, the red-brown colour of iodine. What will happen to the chlorine? The chlorine is taking the electrons from the I minus here, so you form 2 Cl minus ions. You don't observe that happening, but you do observe the red-brown colour of iodine there. And then in the last test tube, they have, again, I minus ions, because you have Ki again in here, but this time instead of the chlorine water they're putting in bromine water. Now bromine is higher up than iodine, look, so bromine is more electronegative, so bromine takes the electrons from the iodine, or the iodide ions and you're forming your iodine there, and what happens to the bromide? Gains 2 electrons, forming 2 Br minus. Okay, so because bromine is more electronegative than iodine, it takes these electrons away. So the bromine is more electronegative, so the bromine is reduced, it gains electrons, and the I minus ions are oxidized, and you form iodine. Again, how do you observe that? You see the red-brown colour of iodine. Now, one reaction that they do not do, lads, right, is they don't show you, they don't have Cl minus ions in here because nothing is going to take the electrons from the Cl minus. So they don't put in bromine water. The bromine is not more electronegative, so it's not going to be able to take the electrons from chlorine. So they don't show you that. So it's just those 3 that are in your revision book, and then the 2 other tests